So we're here at the example table, and in this video we're going to sketch the graph of the function negative e to the 1 minus x. So as always, when we're sketching graphs of functions, it's good to start with something simple. So let's start by graphing just plain e to the x. This has what I hope is the nice familiar exponential graph form. So it looks like this, and it passes through the point 0, 1. Has an asymptote along the x-axis. So we have three things to add to this. We need to add a negative outside. We have a 1 here in the exponent. And also, x is not positive, it's negative. It's 1 minus x. So let's first add that negative. It's worth remembering that for any function f, not just this particular one, negative f of x, right, if we have a function, we multiply on the outside by negative. This, well, what does this do? If we take the output and multiply it by negative 1, that's going to flip the y-axis, right? It's going to take positive values along the y-axis, make them negative. Negative values and make them positive. So negative f of x is just f of x flipped over the x-axis, right? This, and you flip it. So this, negative f of x, flips f of x about the x-axis. But what are we doing? We want e to the negative x. Well, we also want this, so it's worth mentioning. We'll want that. We'll do that later. But we have f of negative x. Now, what are we doing? If we plug in positive values of x into f of negative x, then what's inside the parentheses becomes negative. So it's going to behave like f does going along here. Likewise, if you plug in negative values, they're going to turn out positive. So the negative behavior of this function ends up over here. So f of negative x flips the graph of x about the y-axis. So this flips f of x about the y-axis. So if we want to graph e to the negative x, then our negative occurs within the function, right? It's the second line. So our graph of e to the negative x is going to be this one, only we flip it. So it's going to look like this. And we can label this point again if we want to. Now the next thing I want to do is add 1 to the exponent. One thing worth noting, e to the 1 minus x, this is the same thing as e to the negative x plus 1, right? So we're going to look at the form e to the negative x plus 1. So let's do that on a clean sheet of paper. So we want to add 1 to the exponent. All right, let's make a little table. So we have e to the negative x and e to the negative x plus 1, right? This is the same as e to the 1 minus x. So if we plug in, let's say, 1, 2, and 3 to e to the negative x, we get e to the negative 1, right? We get e to the negative 2, and we get e to the negative 3. Right, the x values are occurring in red here. What about on the right-hand side? If we want the exponent here to be the same as the exponent here, what do we need to plug in for x? So to make negative x plus 1 equal to negative 1, we need to plug in 2. Right, so this becomes negative 2 plus 1. So e to the negative 2 plus 1, same as e to the negative 1. What if we want the exponent to be negative 2? Well, then we plug in 3. We get e to the negative 3 plus 1. This whole thing becomes negative 2. And finally, if we want the exponent to be negative 3, we have e to the negative 4 plus 1. So these x values in red are shifted by 1. So if we want this function to behave the way this function does, then we have to plug in a 2 where we would plug in a 1, a 3 where we would plug in a 2, a 4 where we would plug in a 3. So this means that the graph of e to the negative x plus 1 is shifted to the right by 1. Right? 1 becomes 2, 2 becomes 3, 3 becomes 4. So that means that we get a graph that looks something like this. So this is e to the 1 minus x. And now the point that used to be at the origin, sorry, not at the origin, on the y-axis, is now shifted over by 1. So it goes through 1, 1 here. The last thing to do is to throw the negative outside. We already know what that does. This will flip the entire graph over the x-axis. So this graph will look like this. And I guess we have 2 points that we could possibly care about. This is one of them, right, where the original intercept got shifted to. So this is now 1, negative 1. And the only other point of potential interest is this guy, the new y-intercept. But what happens when we plug in x equals 0? We get e to the 1 minus 0, which is just e to the 1. So we get negative e to the 1, which is negative e. So this point here is 0, negative e. And this is our graph.